My name's Linda Olafsen, and I'm a faculty member in the Department of Electrical and Computer Engineering at Baylor University. I've always been interested in being able to explain to my mom or explain to other people why they care about the science that I'm doing, why they care about the applications or things like that, that it's not just this theoretical, quantum mechanical, mathematical thing, but we can actually use this practically. Our grant from the National Science Foundation has the objective of improving the efficiency of devices that emit mid-infrared light. These are semiconductor devices, and like any engineer, we want to say, hey, how can we get the most power out? How can we have the most efficient device that we can possibly have? And so we're trying to find the mechanisms and the failures and the leakage opportunities in order to design them better. Right now, some of the mid-infrared semiconductor lasers aren't very efficient, and they require too much power, or they're too bulky, or they require too much in the way of cooling in order to be able to control them. And so to be able to take a device out into the field, or to be able to use a device practically in a medical sense, you can't do that because the device is too big or requires too much power. When we're able to identify mechanisms that limit the operation of these semiconductor devices, we are going to be able to, one, understand new physics, understand new properties of materials, and be able to apply them to design new materials. We're also going to be able to design new devices that operate much more efficiently. Baylor has a strong emphasis on material science and engineering. We have a new program in that, and are inviting our first graduate students to participate in this program. And one of the parts is that we integrate two-dimensional materials and three-dimensional materials. So three-dimensional materials, think a box or something, and two-dimensional, think a piece of paper. And so we are putting two-dimensional layers of carbon atoms, graphene, on three-dimensional semiconductor materials or semiconductor layers. Why in the world would you do that? We're interested in doing that because those two-dimensional materials are transparent, and they're also highly conducting. This, because it's very thin, I can see through, so I can get light in. And so it's a really special material that we get to use and integrate and try to use that to make special contacts and improve the mid-infrared semiconductors with which we're working. Baylor's a great place to work on this. We're developing a new clean room and getting new equipment in order to study materials both fundamentally and develop new devices. This grant and this project fits in really well with a lot of Baylor's plans and missions and goals that it's been having recently.